Alright, you did not have homework last night, so you should be working in your journal on the warm-up. Okay, the first thing I want you to do is fill in the chart with appropriate inverse operations. So again, if the operation is addition, what's the inverse? Go ahead and fill those out. Then I want you to solve this two-step equation. And I want you to remember what we did yesterday with modeling equations with our algebra tiles. Just write the equation for me. Okay, so Miss Osborne will pause the video and allow you guys some time to work on these three problems. And then when everyone's ready, she'll push play. Okay, so let's talk about inverse operations. Remember, inverse means opposite. And we discussed these when we were solving for one-step equations. So the opposite of addition here is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. And the opposite of division is multiplication. Okay, so you should have had those written down. We're going to need those again today when we're solving two-step equations. Alright, let's go ahead and solve this two-step equation. So this is something that we reviewed from last year, and we'll talk more about this today, especially with distributive property. But the first thing I want to do, I want to get x by itself, isolate the variable. So since I'm subtracting 24 here, we're going to add 24. Let's get rid of the number that's not attached to the variable first. So if I add 24 to one side, that means I have to add 24 on the other. So the only thing left over on the left side is 7x. And the right side, 54 plus 24 is 78. Okay, the next step is to get x by itself. Right now it's 7 times x, so the opposite here would be division. So I'm going to divide by 7. 7 over 7 is 1, which gives me 1x on the left side. Whatever I do to one side, I'm going to have to do to the other. So 78 divided by 7, I'm going to go ahead and plug that in. 78 divided by 7, and it's 11.142857114. I'm going to round to the nearest hundredth, so it'd be 0.14. So my answer here is 11.14. In algebra, we're always going to round to the nearest hundredth here, okay? Not tenth, hundredth. So the second decimal, or the second number after the decimal. Again, we're going to talk more about two-step equations today, so if you didn't get that quite yet, we'll have more practice. Okay, and the last one is writing the equation. Remember, these are our algebra tiles. Yesterday we talked about the key. The big block represents x squared. We'll get more into seeing that when we deal with polynomials. The long rod represented an x, and then the small square represented 1. So if you did this correctly, okay, I have 1x here, and then this would be plus 1, plus 1, plus 1. So the left side of the equation is x plus 3 equals, since these are shaded, that represents negative. So negative 1, negative 1, negative 1, negative 1, negative 1, negative 1. Total, I have negative 6. So your equation that models this would be x plus 3 equals negative 6. And again, we're going to talk more about using these algebra tiles with two-step equations today. So let's go after it right now. Next page of your journal, let's go ahead and head that. This is my page 12. Today we're going to do two-step equations with distributive property. Today is August 30th, 2016, and again we want to make sure that we fill out our table of contents because that will be beneficial when we have quizzes or tests and we can study from them. So again, solving two-step equations. I'm going to put distributive property as well, and this is my page 12. Okay, so go ahead and take a second to head that. Okay, let's talk about a situation. So let's say I'm going to be purchasing, or I'm going to hire someone to come clean my house. Okay, so the people charge $3.95 per hour. So we'll talk about money here. But their initial starting fee, so even just to make the appointment and have them show up at the house, is $19.95. Okay, I want to figure out how many hours they can work if this is how much money I have in my purse. Okay, so let me say it again. I have $63.40. I'm hiring someone to come clean my house. So the initial fee I have to pay them is $19.95. And they charge $3.95 per hour, which is a great deal. So I need to go ahead and figure out how many hours I can have them at my house, because I don't have a penny more in my purse or my house or anywhere. So that's as much as I possibly have. So I'm going to solve this. I want to figure out H, isolate H. So let's go ahead and take away the starting amount. No matter what, they show up, I make the appointment, I have to pay them $19.95. So let's take that away from my total. So I'm going to subtract $19.95 on both sides. So now the money that I have in my pocket, or in my purse, I have $63.40. I take away the $19.95. I end up having $43.45. That's what I have in my purse now after I pay that initial fee. Okay, over here I still have $3.95 per hour. So again, I want to figure out how many hours I can have them clean my house, as long as I stay underneath this amount of money. So right now it's being multiplied, $3.95 per hour, so times H. So the opposite or inverse operation would be division. So I'm going to go ahead and divide that, cancel it out. So H is the only thing left over. Whatever I do to one side, I have to do to the other. And let's figure out how many hours they can clean. So 43.45 divided by $3.95, and it should be 11 hours, which is a long time to clean a house, which is awesome. My house will be spotless. Okay, so that's how I would solve a two-step equation. Now if you think about what we just did, we got rid of the number that's not attached to the variable. So we got rid of what was being added, or in this case it could be subtracted. Then we got rid of the multiplication and division. Whenever you think about this as solving two-step equations, we're going to use the inverse operations. Put a big star by this. And we're going to work GEMS backwards. Now you're going to hear me say a lot, get rid of the number not attached to the variable. That's the same thing as working GEMS backwards. If you think about GEMS, and I want to work them backwards, that means I'm going to be looking at the S first, the subtraction and addition. I needed to get rid of what was being added first. That was the first thing. Then this step right here, to get H by itself, I took care of the multiplication. So you're working GEMS backwards. That's what I always think of. Okay, again, this is two-step equations, so we're going to keep going, get some more practice. This should be review from last year because I know you guys did a ton of this. Okay, we'll start off easy, get a little bit harder. Let's do 12 is equal to 8 minus 2x. Again, line goes down the middle. You have to show me step by step. So I'm going to get rid of the number not attached to the variable. So since the variable is x, this is a negative 2x. Let's get rid of this positive 8. How do you get 8 to 0? That means I'm going to subtract 8. I want to get rid of it. 8 minus 8 is 0, so I got rid of that. Whatever I do to one side, I must do to the other side. So subtract 8 from 12 and rewrite what you have. So I have 4 is equal to negative 2x. Don't forget about that negative. Okay, so we took care of what was not attached. Now let's get rid of the coefficient. So I'm going to divide by the coefficient because again it's being multiplied here, so I do the opposite, which is divide by negative 2, and I divide the other side by negative 2. So 4 divided by negative 2 ends up being negative 2. The only issue with this right here, because that technically is my answer, however, I need to make sure my variable is always on the left side. So x is equal to negative 2. Now it's official. Okay, remember variables are always, always, always on the left side. And again, we can check this by plugging our answer back into the original equation. So here's the original equation. 12 is equal to 8 minus 2x. Wherever there's an x, I'm going to plug in negative 2 with my parentheses. And I'm going to solve it. So again, if I look at GEMS here, I'm solving multiplication first. Negative 2 times negative 2 is a positive 4. 8 plus positive 4 is 12. They're equal, so I know I did it correctly. It should always be able to be plugged in. Okay, let's try this one by yourself. So take a second to solve. 3a plus 12 is equal to 30. Take a second and solve for a. Okay, so first thing I want to get rid of the number not attached to the variable. So I'm going to subtract 12 on both sides. So I end up having 3a is equal to 18. Now it's 3 times a is equal to 18. The inverse of multiplication is division, so I'm going to divide by the coefficient. Divide by 3, that cancels out. Divide 18 by 3, my answer here should be 18 divided by 3, which is a. A is equal to 6. Raise your hand if you got that. Okay, perfect. Try this one, see how many people I can fool. Let's do negative 13 is equal to negative x minus 7. Take a second to do that one, and then when you're done, check with your neighbor that you sit next to. Okay, first thing I'm looking for is the number that's not attached to the variable. So I have negative x minus 7. Let's get rid of that minus 7 by adding 7. So those cancel out. And I'm going to add 7 over to the left side. Okay, again, I'm double checking my work because I don't want to make mistakes. So let's do negative 13 plus 7 is negative 6. So I have negative 6 is equal to negative x. Is that my answer? No, it is not. You can never, ever, ever have a negative variable. Let me say that again. You can never have a negative variable. What number is really sitting in front of that x? Okay, you have to remember that's really a negative 1. So I have to divide by the coefficient. So I'm going to divide by negative 1, which takes care of that negative variable, making it a positive 1. Whatever I do to one side, I have to do the other. Negative 1 goes into negative 6 times. And I'm going to rewrite that because my variable's on the wrong side, so x is equal to 6. Okay, so one of the things you have to remember is the variable can never be negative. So you need to divide off that negative 1. So put a big star there and put a variable can never, in all caps, be negative. We must divide by that negative 1. I'm going to go ahead and highlight that too because that's very, very important for us to remember. Okay, let's get a little bit harder. I'm going to give you two problems next. And with distributed property, so using your knowledge in review from distributed property last week, I want you to go ahead and solve these two. Miss Osborne will pause the video until everyone's done. So let's do 2 parentheses x minus 5 parentheses equals 30. It's your first one I want you to solve. And then your second one is negative 3x plus 6 in parentheses minus 4 equals 26. Go ahead and at least do the first one. I want everyone to do the first one. Miss Osborne will push play when everyone's done with at least the first one. Okay, so now that you've attempted the first one, maybe the second one too if you had extra time, I need to solve for x. So again, whenever we have these parentheses, I need to simplify that. So I'm going to distribute that 2 towards everything in the parentheses. So whenever we distribute, we multiply. So 2 times x is 2x. 2 times negative 5 is negative 10. And that 30 just falls down. So it's just one extra step because now that I took care of the distributed property, I now have a two-step equation. Okay, we want to get rid of the number not attached to the variable. So I'm going to add 10 to both sides. So the only thing I have left over is 2x is equal to 40. And then I'm going to divide by the coefficient. So I'm going to divide by 2. And my answer here is x is equal to 20. Okay? Now this next one has a couple more steps. And we're going to move into this tomorrow, but I wanted to see how well you guys remembered it from last year. Okay, again, I want to get rid of these parentheses. So I have to distribute. Now, there's a negative in front here. I put that for a reason because what number is really sitting there? It's a negative 1. So I'm going to distribute that negative 1 times everything in the parentheses. So go ahead and do that. Rewrite your new line. So you should have negative 3x. Negative 1 times 6 is negative 6. This negative 4 just falls down. And I recopy that right side. So what do you think my next step is here? Again, I want to solve for x. Okay, can I combine anything on the left side? I have negative 3x, negative 6, negative 4. Okay, you should be able to see that I can combine these last two because they're just numbers. So I can combine those two together. So this negative 3x falls down. Negative 6 minus 4 is negative 10. And that equals 26. Now what do you notice? What do we have here? Just a two-step equation. Okay, I'm going to go ahead and get rid of the negative 10. So I'm going to add 10 to both sides. So I have negative 3x is equal to positive 36. I'm going to divide by the coefficient of negative 3. And my answer here should be 36 divided by negative 3 is negative 9. So my answer here is negative 9. Again, I could plug negative 9 back in and it should be equal on both sides. Okay, so that's where we're going to get to tomorrow, but just to give you a heads up, you might see some challenging questions on your homework for those of you that want to progress. So, last thing is let's look at the algebra tiles and modeling them with two-step equations. So, let's go ahead and label in our journal algebra tiles. And as you're doing that, I want you to pull out the blue book underneath your desk and turn to page 10. I call this the homework helper. This is the book that you also have at your house that you can refer back to. If I look under my desk, it looks like this. Texas Algebra 1 at the bottom, it says homework helper. And we're going to open it up to 10, page 10. Okay, so let's look at this example. page 10. They give you the equation here. It's 3b minus 4 is equal to b plus 2. And we want to incorporate this by modeling with algebra tiles. So if you look at the equation, the original, they set up our algebra tiles. We have 3 x's, which represents our b's in this case, minus 4 is equal to b plus 2. So we know how to do that already. It's just we're going to have x's on both sides. So if you think about how we would actually solve this, okay, we want to get our b's to one side because we're solving for b and our numbers on the other. So if I want to put my b's on one side, I'm probably going to take this b and move it to this side. So to get rid of a positive b, I'm going to take it away. So I subtract b, subtract b. So notice they take a b, or an x, away from each side, leaving me with 2b minus 4 is equal to 2 here. This should be like, it should look like this. So now, since I moved all my x's on one side, or my b's, now let's move our number tiles on the other. So since I had that negative 4 to start out with, to get rid of the negative 4, I'm going to add 4 to one side. Those all cancel out. Whatever I do to one side, I have to do the other, so they added 4 here. So now I have 2 x's on the left and 6 on the right. So the last step here is to divide by the coefficient, which is dividing by 2. Now that's hard to show with the algebra tiles, so what they do is they put the x's, and we want to divide up the right side evenly. So since there's 6, that means 3 and 3 can go with each of the x, which means my answer here would be 3. Keep this open and just put it off to the side. We're going to do one more example, and then I'm going to have you look at those questions at the bottom. Let's go ahead and draw a picture for this one. Let's say 2x plus 6 is equal to negative 3. Now we don't need the algebra tiles today unless you need them because you're a visual learner. That's fine. We're going to draw it out so you can stay with me, and then when you work on your homework, ask Miss Osborne to hand out a bag of algebra tiles if you want to use those. So 2 x's, I'm going to draw my 2 rods, and I'm going to label them positive. 6 little squares, and they're all positive, so I'm going to label those 6 positive little squares. And then on the right side I have negative 3. I'm going to go ahead and shade these. 3 negative units. So this is how we should set it up. Okay, the next step here is I want to get x by itself, so I want to solve for 1x. So let's get rid of the number that's not attached to the variable. So if I have 6 here, I want to get rid of these 6. So 1, 2, 3, 4, 5, and 6. If I take away these 6, those cancel out. But whatever I do to one side, I have to do the other. So I'm going to add, or not add, I'm going to subtract 6 over here. So now let's rewrite what we have. We have 2 x's left over on the left is equal to negative 9. Okay, so now I want to figure out how much 1x is. So if I draw my rods horizontally, okay, I need to split up these 9 evenly, or best I can. So there's 1, 2, 3, 4, 5, 6, 7, 8, and I have 1 left over, so I'm going to put that in the middle. But you just know that half goes with that one and half goes with that one. So if you're solving, 1x represents 4.5, or 4 1/2. Now, is that correct? No. Are these positive 4 1/2 or negative? It should be negative, so make sure you check your signs too. So my answer here is negative 4 1/2. Okay? So let's look at it a couple more. What I want you to do is look back on that page that's the homework helper on the 5 questions at the bottom. Somewhere in your notes, which I'm just going to continue right here, I want you to write the equation for, let's just do 1 and 2. So page 10, okay, and I want you to write the equation for number 1 and 2 based off the algebra tiles. You do not have to solve it. So take a couple minutes to do that. Whenever it's done, Miss Osborne will push play. Okay, so number 1, what you should have gotten, this is again on page 10 of your homework helper, is on the left side, how many x's do I have? I have 4 x's, and I have 3 red little boxes, which would represent -3. My equal to sign represents that black line. I have 2 x's here, and a yellow little square means +1. So your equation for number 1 was 4x minus 3 is equal to 2x plus 1. Raise your hand if you got that. Perfect. Okay, let's look at the second one. So here, how many x's do I have on the left? You should have 5 x's plus 2 equals 2 x's, because those are my 2 rods, plus 5. Okay, so again, we'll have some more practice with that. Again, the EOC could show you just this, and your answer choices where you have to write them, or they could give you something like this, and you have to draw the model using algebra tiles. So, I think we're ready to go for our homework. So what I want you to do is, you can put these blue books back underneath your desk. Those will stay there. You'll have this at home if you ever need to refer back to it. And what I'm asking you to do is keep your notes out, because you might need those for homework, but you're going to need a separate piece of paper, and go ahead and head that. So as everyone's putting everything away, keep your calculator and pencil pouch obviously on your desk. Go ahead and take a second to grab a piece of paper and head this. Put your name on the top left, 2-3, today's the 30th, and what period are you in, /Friday. As you're doing that, Miss Osborne will hand out the homework, so take a second to do that. Okay, looking at your homework, it's 2-sided. This is a little longer assignment. You didn't have homework yesterday. 1 through 11 just says solve the equation, check your answers. So again, you're working these problems out. You must show your work on a separate piece of paper. We'll do number 1 together in a second. And then on this line, you're going to tell me what that variable represents. Now I also threw in there some word problems. So the last 4 are word problems. Make sure you answer the question. It says write and solve the equation. Okay, so that's 2 points. What you write and what you solved it for. Okay, so make sure you have those 2 parts. Same thing with these bottom 2, just a different way of asking the question, but use your knowledge based off of what we did today. Let's go ahead and do that number 1, and then I'll show you the back. So on your paper, put number 1. Okay, the equation is -4x plus 7 equals 11. Again, you must show me every single step that you do. So line goes down the middle. I'm going to take care of the number not attached to the variable. So I'm going to subtract 7 on both sides. I have -4x is equal to 11 minus 7 is what? Okay, you should have said 4. From here, I'm going to get x by itself, so I'm going to divide by the coefficient of -4. And my answer here is x is equal to -1. I'm going to circle my answer. Some of you, I would want you to check it, so plug it back in. You can do it in your head or your calculator. Check that to make sure it's a true statement. And then on your paper, I'm going to put x is equal to -1. You can highlight it on the paper. That's totally up to you. So again, show me your work. On the back, I'm not sure what happened here. There should be 17, so you can go ahead and fill that in if yours is messed up. It says write equation that describes the algebra tiles and then solve. So I have a line where you're going to write the equation, and then you're going to solve your work underneath it, and then give me your answer. So for this first one, My equation here is I have 3 x's on the left side, and that equals 1, 2, 3, 4, 5, 6 times 3 rows, which is 18. That's your first, that's point. Okay, so if you don't do that, you lose a point. Now I'm going to solve it. So underneath here, I left you some room. So to get x by itself, I'm going to divide by 3 on both sides. So I end up having x is equal to 6. Okay, now that's not where I want the answer to go. I want you to write it here. So I have x is equal to 6, and I'm going to circle that. So these types of questions are worth 2 points. You must have the actual equation and what that variable represents. Okay, so you'll do that for 18, 19, and 20. And then the last one, 21, I want you to use algebra tiles to draw this. Okay, so you're given this equation, you just have to draw it, you do not have to solve it. Okay, this is due first thing tomorrow in class. Make sure when you turn this in, all your answers are on the original paper, but your work is stapled. You will not get any credit if you don't have your work. Okay, the work is stapled behind the original paper. Okay, work on this until that bell rings. Make sure you put your calculator, everything in your pouch back, and we will see you tomorrow. Have a splendid day.